Hey, welcome everybody to Weekend Sprint episode 4. In today's episode, I will look into observability topics. Specifically, we'll explore Prometheus and Grafana. So Prometheus is an open source monitoring system. Grafana is the system that helps to visualize metrics and build really awesome dashboards. So I will explore both by doing installations from scratch. We'll configure them in sort of hello world approach. We'll play a little bit with the queries, we'll build a couple of dashboards, we'll configure alerts, and we'll get a little bit better understanding what this system are capable for. All right, let's get started. So the first step would be to install Prometheus. There are a bunch of different options how to install it. I would just pick the Docker option that is quite simple. And So the Docker way of installation expects the configuration file being passed along the execution of the container. So there is a file called Prometheus.yml, and it contains three major sections. So I got an example here. So we got a global settings. So there are a bunch of other parameters that we can pass to Prometheus. One of that we can see here is the scrape interval, which is set to 15 seconds, meaning that Prometheus will pull data from the endpoint every 15 seconds to get new values. Then we get a rule files, and then we get a scrape configs. So with the scrape config section, we say what are the endpoints we want to use for scraping the data. So currently I have three, well, they are called job names, and this is how we can also refer to them using our query language. But what is the most important here is the target. So we get three targets. We have the first one, which is Prometheus itself. So Prometheus exposes metrics of itself, which is a good starting point. So we can start metrics of Prometheus itself. And then I have two other targets over here. So one is my laptop, and the other one is just a virtual machine, which uses the same method of exposing metrics. So I'll just go ahead and get the Prometheus container up and running. So I'll just use the kind of um, a snippet from the documentation of Prometheus. So we just want to use the detached mode. So we don't want to stay within container when we execute it. And then we want to map port 1990 to the host port 1990. And then we also want to pass this Prometheus.yml file to the container, and we want to make it available on the path etc Prometheus YAML. And then this is the Docker Hubs image. So we'll use the latest image of Prometheus. So because I have this Prometheus YAML file in place, I'll just paste this to my terminal, give it a go, and sounds like I have Prometheus up and running. Let's just quickly check it. So we'll go to localhost 1990, and it sounds like indeed we have Prometheus up and running here. So the very first thing I'd like to check is to go to status targets, and in status targets, these are the targets that I defined to scrape. So at the moment, we only have localhost 1990-/metrics. So this is basically, just change this to localhost 1990. This is Prometheus itself exposing metrics. And this is what Prometheus already started to scrape. So basically scrape its own metrics. So there are a couple of others I mentioned. Let's fix this one. So this is my Linux machine, and what I will do, I'll just use one of the exporter that Prometheus offers. And by the way, if I go to Prometheus website, there's exporters and integrations. There's a whole bunch of different software that we can use to integrate or to expose metrics of various targets that Prometheus can scrape. So basically, I'll go was this one. So this is the node exporter. This is the utility that can expose hardware and kernel metrics. And yeah, there are different architectures supported. And what I'll do, I'll just pick the right architecture for my use case and execute the exporter. So over here, I got a Rocket Linux. So that's already with the node exporter downloaded, and I'll just execute it like this. And we can see that it started to expose the metrics. So I'll just go back to Prometheus list of targets and refresh the page and see, okay, so we've got a endpoint with Rocket Linux up, meaning that Prometheus started to collect metrics from these target. So if I click on a graph, this is where we can start doing the queries. So there are like different queries available. So since we introduced the node exporter, everything which starts with node underscore would bring us everything that node exporter offers. For example, I'll just go for something like not CPU seconds total, and if I execute, that returns the current value. So I can also go for graph vision, and if I make it, let's say 5 minutes maybe, and if I show it in stack version, so these are my CPU metrics that I exposed from that Rocky Linux. So we can see that the job name is Rocky, the instance is Rocky, with the port definition and different modus of my CPU here. So there's also a globus icon, and with the globus icon we can explore all other metrics. Well, not explore, but we can take a look at all other metrics that are available in the list if we don't know what to start with. So the other one would be something file related, for example. So let's take a look at the file system available bytes. And if we execute it, oops, so just remove this part. And if we execute it, so that returns the available disk space on various mount points. So for instance, this is the green one is the slash mount point, and we can see that it has like slightly below 12 gigabytes of space. All right, so this part is clear. Let's just go ahead and explore Grafana because we want to visualize the data and build like different dashboards. So just pick this particular snippet, which is again taken from the documentation of Grafana. So pretty much the same approach like we did for Prometheus. So we want to detach from the process, give it a name. We want to export port 3000 on the host, and then we want to pass the volume. So we keep persistency of the like data that Grafana generated, and then a couple of variables like environment variables that we can use later on. So these are like 4 variables that I want to use to configure my mail server, and the mail server will be used for alerts as a contact point, but we will explore that like in a minute. And again, so the Grafana / Grafana OSS, this is the official image coming from Docker Hub. There's also enterprise version available, so it's going to be different image, of course. So I'll just paste it to my terminal, give it a go, and sounds like we have container up and running. And if I just go here and do localhost 3000, that brings me to the login page of my Grafana instance, and the admin would be the username and password. And of course, on the first login, it asks me to change the username and password. I'll just use the same for the demo purposes. And this is the Grafana welcome screen. So from here, it's quite um, easy to figure out what to do. So basically, the first would be to define the data source. So because Grafana itself doesn't have anything yet, so we have to say where to collect data for Grafana, and that's going to be the data source. So we just go for data source, and then there are a whole different bunch of data sources available that we can use. So I'll just go for the first one, which is Prometheus, since we have Prometheus up and running. And so there's only URL needed for now. Of course, later we can look into authentication and a bunch of other settings. But for now, just need to define the URL of my Prometheus, which is going to be, I think it's going to be host docker internal, and then because it's on port 1990, that's the port that we have to define. So why is this? Because both my Grafana and Prometheus are up and running as a container on my Docker machine, and I didn't have any network configuration made specifically, so I cannot really access like, yeah, I don't really have any common network for the containers at the moment. So the easiest would be to call the host's IP or the host's the host name of the Docker machine, because it also exposed within this port, and it serves the Prometheus on this port. So this should work. So just give it a go, and looks like it found Prometheus on this endpoint, and it can basically scrape the metrics. Well, the data source has been configured. The next step would be to start building the dashboards, and we can just go here. So we start with the new dashboard, and we start with the new panel. And so this is the view from where we can start crafting our dashboard. So again, over here, we get a metrics browser in the same way like we saw in Prometheus, and then we can just start doing search. And let's say if I go for node CPU seconds total, and if I go for the last 5 minutes, for example, it says that the selected metric is countered, meaning that it's just constantly increasing, and it's not that interesting to visualize these particular metrics, but there is a recommendation what can be added to this query, and it's going to be a rate. So if I do the rate, then it's going to be a much better view. So we can see what is going on with my processor. So I'll just go ahead and grab a couple of queries that I want to explore. So the first would be the node time in seconds. So let's just take a look at the time at the time of my node being up. So we're querying this Rocky node, and what I'll just do, so first make a change is going to be uptime, maybe node uptime. Okay, so we got a change over here, node uptime. So the other thing that I want to change is to define seconds. So it's going to be seconds, and it's immediately translated that to the human type of like time. So basically I can understand that like this gazillion amount of seconds is equivalent of like roughly 1.5 weeks. Okay, this is good. And then what we also can do is change the how we want to visualize it. And for that, we'll just go for something like this. So it's going to be just a box where we show, we don't really want this as well. So where we just show the value. So yeah, we can also play with a bunch of other things. Um, yeah, for example, here we can change the legend, but yeah, that's not relevant for this use case. I'll just look into the next query and this, but yeah, for now this part is done, so we can just apply and put it over here on the dashboard already. So I'll just make it a little bit smaller, and on this dashboard I can clearly see that my node, so my Rocky node, has been up and running for like almost, yeah, 1.5, like somewhere between 1.5 and 2 weeks. So I'll just go ahead and add another panel. And so my second query would be the query on the storage. I'll just pick this query from my README. So basically, what we are trying to do here, we're trying to show the percent of the disk utilization on our system. Not disk utilization, but the percent of the file system mounts utilization on this target. And for that, we use two metrics that we scrape. So first one is node system available in bytes, and we multiply that by 100. And then we use the node file system size in bytes. So basically available bytes and total bytes. So from that, we just calculate what's the free space on the storage. So just give it a run. And over here, we just see all the targets. So we have, so let's just actually make the legend a little bit simpler. So by default, it automatically show us the whole information from the scrape target, like the device name, the file system type, the instance type, the job. But by the with the legend customization, we can say what exactly we want to see here. So for example, I want to see only mount point. So I can define it like here, like it's like using double curly braces. And if I run the query again, so we can see that it's much simpler right now, but it's also easy to read, easy to explore such graph. We can also switch to a different view, so we can also use the stacked area. So here we can define the storage space. We can also say these are in percent from 0 to 100. So we can also maybe remove the points. And how about we make the graphs like this? And I think we're good for now. So basically, what we are showing here is we are showing the amount of free space available on the mount point in percent. So if I look at the green, so my green has 34%, 34.6% of free space. And if I just go to my machine, just log into this machine, and if I do df dash h for human, so we can see that indeed my mount point slash has like 35% roughly of the storage space. And if we, let's say, create a file here, like of 10 gigabytes, and if we go back to the metric, so if we save it, and if we define that we want to refresh every 5 seconds, we see that there is a spike. So basically there is an increase of the storage utilization. And it's now, so this is boot, it's now a 95%, 95.6%. So later, we will use this approach to define alert. We will set the threshold, and we will just alert ourselves on this particular spike. So let's just go back here and explore one more metric, one more metric. Yeah. So just go again and build the new panel. So we paste the query over here. So what we're trying to do here is basically we want to find out the average CPU utilization in our system, and we want to convert that to the percent. So in this way, we can see how we are doing in terms of the CPU utilization. So just build this graph first, and I'll just swap the units to percent again, like I did for the storage. So on average, we can see that we are somewhere around 80% of utilization of our CPU for the last 5 minutes. And if it's like change to 15 minutes, so we see that it's basically went from 100% utilization to like 87% utilization. Yeah, I'll just leave it like this. Maybe we can also pick something better for visualization. So how about this one? So then we can also see that the peaks are like dangerous red. And here again, I want to, okay, so I'll just leave it like this. And maybe I can change the customization like CPU, like CPU Rocky. Okay, so we're gonna save it. Let's just adjust the width of the panel. Maybe we can also change the title, like CPU utilization for now. So we just save it. So this is our dashboard. And once again, if we visit the storage dashboard, maybe we can do something like this. So we can change the line interpolation, how they're like, what is better for us, like for our eye. Okay, and I want to explore a little bit more around memory as well. So I'll just pick this query and I will paste it. I'll paste it to my panel over here and explain. So basically what we're looking here is we're taking the memory free in bytes for the last 10 minutes, like on average. And then we are looking for the cache bytes again for the last 10 minutes, average over time. So the buffers and then the memory total. And again, we just calculate the total amount of free memory available in percent. So for that, we just run a query and looks like over the time, on average, we've been increasing. And now we are somewhere around 56%. Let's, by the way, change the units to percent. So it will make sense when we look at the graph, and also change the title to memory usage. And so here with the legend, we can just say that we want to use the job. So this will show us, because if we have more targets in our scrape data, then we can say that like with this, using the job legend, we can say what we want to show on the target and what we want to show on the graph, and then it will be easy to differentiate those graphs by just using the name of the job. We can also take a look at the suggested visualization. So, for example, we can pick the bar, or I can pick like I did for the CPU utilization. So this sort of graph type, but I'll stay with this one, just the standard linear. The other one, if we go to Grafana website, so if we just get started from here, on the main page we get a dashboards link, and if you go to dashboards, what we can do, we can just search for node exporter. So it's like a catalog of various dashboards that we can reuse. And then the one I wanted to show is the node exporter full. So just go here. There is a rate with the reviews. The reviews are pretty high, so 5 stars for the dashboard. So there's an example how to scrape the data to for this dashboard. And there's also information what data source is expected for the dashboard. So what I'll do, I'll just click copy ID to clipboard. There's also a way to download the JSON, but I'll just get the ID and I'll just go back to my dashboard over here. Not the dashboard, but yeah, here in the configuration of dashboards. And if I say import, so we're just gonna save that dashboard first. And if I import new dashboard, what I can do, I just can paste the ID that I took from the website with the dashboard catalog. And if I load, it says, all right, I'm node exporter full, so that's exactly what we saw. And the only thing I need to pass over here is the data source, which is Prometheus. So, okay, I'll import. And what we see is a whole bunch of different widgets on the dashboard that we can use to explore our scraped data from Node Exporter. I'll just make it last 15 minutes because that's how long we've been running this Node Exporter on the Rocket Linux. And we can see a whole bunch of interesting insights about that target. So basically CPU, memory, network, and then there are also a lot of things over here, like explaining what is going on with your CPU, net, and disk. So that's pretty much what we did recently on the memory stack. So there's also disk space utilization. We see this spike. So we also saw that in our dashboard, in our query. So these are also various mount points, and then over here we also have some legend saying that max, mean, last, mean, these sort of values. So yeah, this existing dashboard is always nice to explore and see what kind of insights you can get from your data because it's already explored and someone already put a lot of effort in it. So the next step for me is to play a little bit with alerts. So first, what I'll do, I'll just go ahead and remove that large file from the system. And make sure that I still have enough space in that mount point, so 35%, which is good. So that's what I wanted. And then before we are going to set up alert, I want to do something else. So I want to run the maildev server. So that's really handy when I want to test something. So I just can put the dev mail server in between. It's pretty much taken from the maildev server's documentation, again, like detached from the process and expose a couple of ports, and then we're good. So basically, there's a web UI of that maildev server. I'll just keep it open here because we exposed that. We exposed that on this host port. So this is my maildev server. So anything that I send to send from Grafana using this SMTP relay, because we also exposed this SMTP port, but we didn't define any username and password, so it's just without authentication. So what I'll do, I'll just set up the contact points in my Grafana first, so that I can use this this SMTP relay to send notifications. And for this, I'll just go here, alerting contact points. And then there's already default Grafana default email. And I'll just edit this for now. And remember, because we executed our Grafana with those environment variables, so we are pointing to the SMTP host Docker internal with this port. So that's exactly what we expose here. So basically, there's no username and password defined. There's only flag to enable SMTP, and that's how Grafana picked this. So if I just use some email here, and if I just test it, send notification, and we immediately see that there is a send notification over here. So we can see that we just received a test email from Grafana. Okay, so this part works. We just close this, save contact point, and with this, we are good for now. So the next would be to configure the alert rule, and for that I will just use the query the query to query the disk space. So the idea is that I want to alert when the free space on the storage is below certain threshold. So for this, what we can do, we can take a look at the query that we used for the disk space. By the way, so look, like this spike went down back because we deleted the file. So if I go here and if I pick up the query that I used recently, I'll just use the same query to set up my alert. So for this, I'll just go here, alert rule, create alert rule, and I'll just use the Grafana managed alert. The data source will be Prometheus for me, and then I paste the query over here. So again, I want to calculate the amount of free space on the mount point in percent. And maybe in addition, I can also define that I want to do it specifically for this mount point because I want to alert only when I have low disk space on this particular target. So this is first we run the query. So this is the query. This is the current situation on the storage on this mount point. So what we can do, we can say that. So first we want to reduce this. So basically, we want to find out from this information the number that we want to work with. So that's going to be the percent of the available free space. And then the next iteration would be to compare this value with the threshold. So basically, we do it like this. So $B referring to the reduced value, so basically to the 34. And if we are going to check it against the threshold of 90, that would be great. So basically that's how we test it. So as we can see, if we are checking against that 90%, so then it's good. And let's just validate that it's working good. So basically there's a 34%. And if you say that if it's below, then it should give us the alert. So if you do it like this, so is B more than 30%? Is it more than 30%? Yes, it's more than 30%, then it's firing. So firing means it's alert. So we'll just put it back to 90% because we want to alert when it's only 90% disk space used. So when there's only 10% left, we want to alert we want to alert on this. So that's the rule, and that's the query that we want to use. And there are a couple of things that we want to define on top of this. At first, um, we want to define a folder, so that's going to be storage. And I want to do this every, let's say, 10 seconds. And so what I want to do, I want to evaluate this every 10 seconds, and I want to do it for 20 seconds, meaning that every 10 seconds I will evaluate this value within 20 seconds. And if it stays the same, then I will start to learn. There is a summary, the disk space left on mount point slash is less than 90%, sorry, 10%. We can also add description. There is way to template the alert, so we can also use the labels, for example, here, and this information will be passed along with alert itself. So there will be summary and description, and we can see certain values in that email. So last but not least, there is also a way to play with the label. So for example, if we have the contact point defined and we can use the labels. So for example, we can say team here and we can define the ops, and then we can add another one, purpose, and we can say demo. So these are the tags that will be associated with this particular alert, and then I can also configure those labels on the contact point. But for now, it's just going to be the default contact point. And if I go ahead and click save here, oh yeah, of course, storage usage alert. If I go ahead and click save and exit, so we see that it's currently normal. So it's gonna evaluate for the next 20 seconds, every 10 seconds, this value, and if something goes above the 90%, which is our threshold, then it will fire alert. So we just wait a little bit and see. So there's nothing wrong. It's been already evaluated at least once, and there's nothing wrong. So let's just go ahead and add that dummy file to the system. So we will go above the threshold. So we just allocate the 10 gigabyte file, and then let's just make sure that we are above the 90%. So yes, indeed, we are above the 90%. And if we go back here and sit for a second, we'll see that it will evaluate this for the next 20 seconds twice, because there's every 10 seconds, because it wants to make sure that there's nothing fishy, yeah, there's not false positive. And as we can see, there's already pinned in, meaning that it found like the threshold match. Now it's just going to evaluate this again. And at some point, we'll see that it will fire alert. Yep, firing. And we just need to wait a little bit in order to receive email. There we go. We got an email arrived stating that our value B equal to 95%. Is it 95%? Well, it's like 96. And yeah, it's average. And then it's just stating some information taken from the alert. So I tried to use the label for the template. I failed. Yeah, probably I have to use a slightly different approach, but yeah, that's the summary that we sent along with the alert. And then yeah, some information can be also added from the actual values. I think we can conclude that we just explored how to deal with Prometheus and Grafana, how to expose metrics and how to scrape them, how to build dashboards, and how to configure alerts. Thank you very much for watching.